Hello, find the Fourier series where we'll discuss the problem about the Fourier series. So find the Fourier transform of the signal x of t is equal to e raised to power minus at into u of t. Plot its magnitude and phase plot. So solution. So we have to find the Fourier transform of the. So Fourier transform is x of w is equal to Fourier transform of x of t. So the equation is x of omega is equal to minus infinity to infinity x of t into e raised to power minus j omega t into dt. So put value of x of t, limit minus infinity to infinity. X of t is given, it is a e raised to power minus at into u of t into e raised to power minus j omega t into dt. So these two terms are there. U of t is nothing but the unity function, and it is equal to 1. Therefore we can write here, and we can change the limit 0 to infinity, and the unity function is from the 0 to plus infinity on the right hand side of the equation. So therefore we have to change the limit, and this is a e raised to power minus a plus j omega t into dt. T we have to take outside. T also we have to take outside. So the it is minus 1 over a plus j omega into e raised to power minus a plus j omega 0 to infinity. X of omega is equal to minus a by a plus j omega. After substituting value e raised to power minus infinity minus e raised to power 0 and e raised to power, if you put here this value is 0 and this value is 1, you'll get here minus 1 over a plus j omega 0 minus 1. This is equal to 1 over a plus j omega. So we have to find now the phase and magnitude plot. So this is the x of omega. So magnitude of s of omega is equal to 1 over square root of a square plus omega square, and its angle is x of omega is equal to minus tan inverse of omega by a. So if you put values of the different frequency in this plot, we will get the different magnitude of this function, and if you also substitute the frequency, different frequency, we'll get the different angles. So we'll find first the magnitude plot. Now for suppose omega, and we'll find x of omega magnitude. When you put here omega is equal to 0, what we'll get here? We'll get here 1 over e. And if you calculate here, suppose minus infinity, even though we'll get 0, if you put 0, we'll get also 0. So this is the magnitude plot, and we can calculate this magnitude plot like this. So this is x of omega versus the frequency. This is frequency on this side, it is a plus infinity, and this is on this side, it is minus infinity. This is omega. So the magnitude is 1 over a, and the plot is like this. At plus infinity, we'll get the magnitude like this. At negative, we'll get like this. So this is the even symmetry. This is also called as the magnitude plot. This is the magnitude plot. Now let us go for the phase plot. Phase plot, we know that the angle of x of omega is equal to minus tan inverse of omega by e. So this is omega, and this is the angle x of omega. So when omega is equal to 0, this is also 0. When omega is equal to minus infinity, in this case, we'll get it is a minus pi by 2, and therefore it is a pi by 2. And when you put omega is equal to infinity in this equation, we'll get this value of pi by 2, and this is a minus pi by 2. So from this plot we can draw the phase plot. So this is the phase plot. So this is the 0 frequency. From this it is a plus infinity, from this is minus infinity. So here it is a pi by 2, angle is the pi by 2, this is pi by 2, and this is minus pi by 2. So when it is 0, it is 0, and at minus infinity it is a pi by 2. So it is a pi by 2, like that, just like that. Okay. So at minus infinity it is a pi by 2, and at plus infinity it is minus pi by 2. So this is the phase plot, and this symmetry we can call it as this is odd symmetry. So in this way we can find the Fourier transform of the given function. Thanks for watching the video.